Good evening, students. I hope you are ready to learn something new this time. Not new exactly. We are all gonna continue the chapter, which was differentiability. So let's continue with differentiability. So differentiability, as we have seen, we had done till here, I guess. Last question we did was the last part of differentiability. After that, we are going to do is the first principle of derivative. The first principle of derivative. So yeah, let us see what is the first principle of derivative. So basically how all your differentiation formulas came. That is how we know कि derivative of sin x is cos x, derivative of tan x is sec square x. So similarly, when those formula were derived by using first principle, it is called first principle of derivative. So that was we are talking about here, the process of finding derivative of a function from the definition. As you know, what was the definition of derivative? This f dash of x means f of x plus h minus f of x upon h as limit h tends to 0. So let us try to get the formula of x raised to n. As we all know, if x raised to n is the function, then what is the derivative? It's n x raised to n minus 1. So let us derive this formula using the first principle. So here f of x is basically x raised to n. So as you can see the formula, we require f of x plus h. So what will be f of x plus h? It will be x plus h raised to n. Okay. So yeah, what will be f dash of x now by using the formula? Let's substitute the values in the formula. It will be limit h tends to 0. F of x plus h means x plus h raised to the power n minus x raised to the power n upon h. Now let's check indeterminate form. N minus x raised to n, which is 0, and denominator also has 0. So which indeterminate form it is? It is 0 upon 0. That means we can use what? We can use L'Hopital's rule. Let's use L'Hopital's rule. So I will get limit h tends to 0. What is derivative of nx x raised to n? We all know this is the derivative. So n x plus h raised to the power n minus 1 minus n x raised to the power n minus 1 upon we did some mistake, right? Yeah, the their derivative will be 0 because it is constant. X raised to n is constant. So it will be 0 upon derivative of h is 1. So now the indeterminate form is gone. So we'll use direct substitution. Substitute h equals to 0 here. We'll get n x raised to n minus 1. So that is how we get this formula. I hope you'll remember this formula because in the next question, again, we are going to use it. So let's proceed on to the next question and see what is the derivative of sin x with respect to x. So do you know the formula? The formula was f dash of x is equals to limit h tends to 0 f of x plus h minus f of x upon h. So here in place of f of x, what do we have? In place of f of x, we have sin x. right? And therefore, in place of f of x plus h, what is in place of f of x plus h? Then it will be sine of x plus h. Correct? So let's substitute all this in the formula to get f dash of x. So now f dash of x will be equal to limit h tends to 0. F of x plus h is sine h, sine of x plus h. Just substitute the value here. Minus f of x is sine x upon h. Now let's check the indeterminate form. If I substitute h equals to 0 here, I will get sin x minus sin x in numerator, which is 0. And in denominator also h is 0. So that is 0 upon 0 form. So that means we can use L'Hopital's rule. We will get limit h tends to 0. What is the derivative of sin x? Cos x plus h. Please remember here the variable is h. So that means we have to consider x as a constant. So if I consider x as a constant, then derivative of sin x will be 0 upon, and derivative of h will be 1. So as now indeterminate form is gone, so we can directly substitute a value of h. So if I substitute h equals to 0, I will get simply cos x. That means f dash of x is cos x. So that means derivative of sin x is cos x. So this is the formula from which we get all our formulae. All the derivatives formula we get from this. It is very simple. Just substitute the functions and use L'Hopital's rule. So let's take another. It's getting interesting. A raised to x. Do you know a raised to x? Formula for derivative of a raised to x? It is a raised to x into log a. So what was the formula again? F dash of x is equals to limit h tends to 0. F of x plus h minus f of x upon h. So here, in place of f of x, we have a raised to x. So that means f of x plus h will be equal to a raised to. I hope it is clear. So now, if I substitute here, f dash of x will be limit h tends to 0. A raised to x plus h minus a raised to x upon h. Let me point it out here again. The variable is h. That means a quantity having x will not be a variable. We can treat it as constant. Let's check in determinant form. If I substitute h equals to 0, I will get a raised to x minus a raised to x, which is 0 upon 0 format. So that means I can use LH rule. So I will get limit h tends to 0. What is the derivative of a raised to x plus h? It is a raised to x plus h into ln a minus. What is derivative of a raised to x? It is 0 and derivative of h is 1. So let us substitute h equals to 0. H equals to 0, I will get a raised to x ln a, which is my formula for a raised to x. I hope it is very clear now. So let me try just one last example, which is not our standard formula, which is derivative of log x. This is an interesting example because till now we were deriving the standard formula. Now this is log x derivative. As you can see, it is a composite function. That means if we do it normally, we should use chain rule. But since we are doing with first principle, there is no need to use chain rule. So let us see. The formula was limit h tends to 0 f of x plus h minus f of x upon h. So here in place of f of x we have log of 3x plus 2. That means in place of f of x plus h we will have log of 3 and 2 x plus h plus 2. So let's substitute both in the formula. So my f dash of x will be equal to limit h tends to 0. What is f of x plus h? It is ln. If I open the bracket, it will be 3x plus 3h plus 2 minus ln 3x plus 2 upon h. Again, who's the variable here? It is h. That means a quantity having x will be considered as constant. So I will, if I let's check indeterminate form. So if I substitute h की जगह पे 0, ऊपर I will get 0, ln minus ln, नीचे I will get 0. That is 0 upon 0 form. So that means I can use LH rule. Let's use LH rule. So limit h tends to 0. Log x. Log x derivative 1 upon 3x plus 3h plus 2 into 3. Don't forget into 3 because it is xh ka coefficient. Minus, this is a constant, 0 upon 1. Now, indeterminate form is gone. So that means I can substitute h equals to 0. If I substitute h equals to 0, I will simply get 3 upon 3x plus 2. So this is my answer. Log of 3x minus 2, the derivative is 3x minus 2. Oh, I guess we did slight mistake. Just here we had minus. So it will be 3x minus 2. We had minus, na 3x minus 2. Bye. So I hope it is very clear to you the first principle. Okay. So now differentiability is over. Till now, what do we studied? We were studying calculus. Calculus helps us in defining nature of the function. You might be getting bored because I am repeating the same thing in a lecture at least 2 or 3 times. But hear me out, this shouldn't go out of your mind. Limits gives us behavior of the function at the neighborhood of the point, while continuity helps us to find whether the function is broken or not. And lastly, derivability helps us to, differentiation helps us to know whether the function has a sharp edge or not. Or what do we call it as? We call it as whether the function at every point can be drawn a tangent. Right? So we have completed with differentiability. So next we are going to start with is differentiation. Now, what is differentiation or derivatives? You all know this, differentiation and derivatives. What is derivatives? We have studied the formulae, if you remember, in limits itself. So, differentiation, we are going to cover the basic formula which we have seen, the rules of derivatives, then the most important derivative of composite functions, which we get it by chain rule. And lastly, again important, higher order derivatives. Higher order derivatives, basically there are many prove that types questions which comes in higher order derivatives. So yeah, that is also important. So let us start with again the basic formula. Basic formula you all know. F of x, f dash of x. There are basically, according to me, like I like to divide. I have taken this idea from integration. There are 5 types of functions, right? If you know integration, you know what I am talking about. If not, it's okay. We'll study. There are five types of functions which we format it as LIATE. LIATE, where L stands for logarithmic functions, I stands for inverse trigonometric functions, A stands for algebraic functions, T stands for trigonometric functions, and lastly, E stands for exponential function. So if I say like from upper say like in the big picture, function may we have this five types, which we abbreviate it as LIATE. So here all the formulas that we are going to do in derivatives, integration, and we did it in limits. Those all formulas are for these five functions. As you can see here, log is there, exponential is there, all the trigonometric functions are there. This is basically algebraic. X raised to n, a polynomial, it is basically algebraic. The one missing are inverse trigonometry. That we are going to study separately because that is a separate topic, main topic in derivatives. So, just a brief on if you don't remember the formula, how to remember it. I basically remember it like this. I have abbreviated it as LIATE, taken this idea from integration, and all of my formulas of derivatives and integration are basically of LIATE. Log function, inverse trigonometry, algebraic trigonometry, and exponential. Out of which inverse trigonometry is not. After this, we will study the rules. There are in total 4 rules, or you can add it one and say 5 rules. So the addition and subtraction rule is same. If two functions are getting added, then when differentiating, their derivatives will also get added. If two functions are getting subtracted, then after differentiating, their derivatives will also get subtracted. Now, these two rules are important. That is the product rule and the division rule. The product rule and the division rule. So the product rule states that if two functions are getting multiplied, then their derivative is given by u derivative of v plus v derivative of u. And similarly, when the quotient, when we have quotient rule, then the formula is given by v derivative of u minus u derivative of v the whole upon v square. You are all familiar with this formula. And one thing, that if a constant multiplies with a function, then it remains as it is. Now let's take an example for this. That means if my function is y equals to 3 sine x, then if I take derivative dy by dx, then 3 will remain as it is, since 3 is in product. And I simply take derivative of sine x, which is cos x. This is my formula. Simple. Now, if you are all done with rules and formulae, let us then go down to the major topic, which is the chain. So, chain rule is basically used for derivative of composite functions. I hope you know what are composite functions. When two functions are such that one of them is inside one another are called composite function. For example, suppose sine of log x, sine of log x. The original function was sine x. Here, x is replaced by log x. That means then we'll get sine of log x. So this is called composite functions. So now let us study what is chain rule. Let me make this one thing clear. If f is a function of x, then f can only be differentiated with respect to x. Please make this very clear. Hear me clearly. If f is a function of x, then I can differentiate f only with respect to x. I cannot differentiate it with another variable. If I try to differentiate with another variable, my answer will be 0 because x then will be treated as constant. So let us say y is a function of u is a function of v is a function of w, and w is a function of x. So that means if I change x, w will change. If that means v will change. And if v changes, u will change. And if u changes, y will change. So that means indirectly y is dependent on x. If I change x, then it forms a chain. And finally, it also changes y. That's why the rule is called chain rule. So, if someone asks me to find dy by dx, don't misunderstand me, but I can differentiate y with respect to x because here, as x changes, y changes. But y is a function of u. So that means I can differentiate y only with respect to u. Now what will I do? I'll say let u be differentiated with respect to x. What can I do? Since y is a function of u, it can only be differentiated with respect to u. Now, same problem comes with u. U is a function of v. So that will tell us that I can differentiate u only with respect to v. Let v be differentiated with respect to x. Now same problem comes with v. This will remain same. V will say I am a function of w. So let me be differentiated with w and you differentiate w with respect to x. So basically this forms a chain of derivatives which we need to multiply to get our final answer. So till now we have studied chain rule. And if we want to study chain rule or if we want to understand it better, we'll take some examples. Which starting we'll do only by using this, the chain formula. But after that, we can directly do it as we have all been doing. So let us take this example. Y is equals to sine of log x. So if I take u as log x, then I will get y as sine u. That means y is a function of u. That means I can differentiate y only with u. So if I try to differentiate y with respect to x, he will tell me, he differentiate me with respect to u and let u be differentiated with respect to x. Now, since u is a function of x, it can be differentiated with respect to x. So let's go. Sine u, derivative of sine u is cos u, and derivative of u means derivative of log x is 1 upon x. Let us resubstitute the value of u. So I will get cos of log x upon x. This is my answer. Simple. Derivative of sine of log x is cos of log x upon x. So same in the second question. Let me again, let's take y is equals to, okay. So let me again say that u is equal to x raised to 5 plus 4. So that means y will be equals to log u. So that means if I want to find dy by dx, y can only be differentiated with u. So he will tell me I can be differentiated with u. You differentiate u with respect to x. So now if I differentiate log u with respect to u, I will get 1 upon u into u can be differentiated with respect to x. So if I take this derivative, we'll get addition rule. So I will get 5x raised to 4 plus 0. Now let us resubstitute u. So I will get 5x raised to 4 upon u is x raised to 5 plus 4. This is my answer. It's very simple. This chain rule is very simple if you understand one thing, that if y is a function of u, it can be differentiated with respect to u. Then let u be differentiated with respect to x. So this basically at the end forms a chain. Got it? Yeah. So I hope these examples were enough to understand chain rule. And if you have any questions, you can bring it to me now, or you can bring it to me next time or any time during the lecture. So let us now move on to the next topic. Do you remember what was the next topic from the content side? We were going to study chain rule, and after that, we were going to study higher order derivatives. So, what are higher order derivatives? Let me give you an idea. Suppose, before moving on to the next slide, I have a function x raised to 5. I differentiated it one time, I will get 5x raised to 4. If I differentiate it again the second time, then I will get 20x raised to 3. So when I differentiate a function two times, the first time, then the second time, it is called second order derivative. It's as simple as that. If I differentiate it third time, it is called third order derivative. So if I differentiate it n times, it is called nth order derivative. It's so simple. So basically, higher order derivative means if we differentiate first order derivative again, then we get second order derivative. Similarly, if we differentiate second order derivative again, we get third order derivative. So let us talk about notations. As you all know, first order derivative for the function y equal to f of x is y dash is equals to f dash of x. So what about second order? Second order is y double dash, f double dash of x. And I can write first order as dy by dx. I can write second order as d square y upon dx square. Now, many people read it very differently. Someone read it as d2y upon dx square. When I was in 11th and 12th, I used to read it as d square y upon dx square. So you can use any d2y upon dx square or d square y upon dx square. No issues. So what will be the third order derivative? It will be y triple dash or f triple dash of x or d3y upon dx cube or d cube y upon dx cube. Anyway, you need to write. So if I do this n times, I will get y n dash. Now, it is not possible to write n dash. So simply write y raised to n. Please don't misunderstand this. It is not y raised to n. It is the nth derivative of y. And same for f of nx, and same d ny upon dx raised to n. So now how the question comes in higher order derivatives. Let's say they will give you a function and they will tell to prove something. Now obviously in MCQs they will not ask to prove, they will give a certain value and we have to find that value. So let us see what exactly are we talking about. So here it is. They have given us y is equals to cos of this, then we have to show that this is equal to 0. What they will do in MCQ, they will just remove equal to 0 and they will say find the value of this. And in options, they will have 0, 1, -1, and 2. So option A, option B, option C, and option D. And we have to find which of the option is correct. So it is very simple and mostly asked questions of higher derivatives, and they are asked this way. So what do? We just see what we need to prove. This is what we need to prove. That means there is d2y upon dx square, which means we need to differentiate the function 2 times. Now, the simple logic which I follow is differentiate the function 1 time, simplify it as much as you can. Getting it? Differentiate the function 1 time, simplify it as much as you can, and after simplifying, differentiate it second time. Now, let me tell you, if you don't simplify the function, then too you will get an answer. Then too you will get an answer. But the main problem would be that you will get many complicated simplification. Like you will have to do many complicated simplification. So we'll see here. We'll see here what I'm trying to say. So to avoid that complicated simplification, don't differentiate twice directly. First differentiate it, then simplify as much as you can, and then differentiate it again. So let's check with this. If I try to differentiate once, I will get dy by dx is equals to. Should I use chain rule here? Obviously, if I consider this as u. So I will get derivative of cos u, which is minus sine u m cos inverse of x. After this, I need to use chain rule. So into derivative of u. What is the derivative of u? It will be m into minus 1 upon under root of 1 minus x square. This is the derivative of cos inverse of x. Derivative of cos inverse of x is minus 1 upon under root of 1 minus x square. I hope you are getting it. So now we said that after taking first derivative, simplify it. So what do I mean by simplification? That means here this minus and minus will get cancelled. So, and I can cross multiply this. So wait, I will get dy by dx is equals to sine of m cos inverse x into m upon under root of 1 minus x square. Now, if you think of differentiating it again, you might see that we need to use u upon v rule. And u upon v rule is a little bit tedious to use. I'm not saying it is like very much difficult, but a little bit tedious. So to avoid using u upon v rule, we simply cross multiply this there. So I will get under root of 1 minus x square into dy by dx is equals to m into sine of m cos inverse x. Okay. So now I will differentiate because here I will use u into v rule, u into v. but it is less tedious than u upon v root. No doubt you will get answer here only. If you use u upon v here, you will get an answer definitely, but it will be more calculated. This is what I mean by simplification. We first take the derivative, simplify it, and then again take the derivative. So now if I take derivative, here I need to use u into v root. So I will get under root of 1 minus x square into dy by dx. We again differentiate, which means we differentiated it 2 times. So what is the symbol? d2y by dx square plus v dy by dx. And what is derivative of root x? It is 1 upon 2 under root of 1 minus x square into minus 2x. Don't forget the chain rule. And what I will get on the right hand side? M is constant. Sine derivative is cos. Cos of m cos inverse x into m into minus 1 upon under root of 1 minus x square. So, if you can see here, let me point it out 2 things. I can replace this with y because it was y. If I multiply throughout with under root of 1 minus x square, let me check. Here 2 and 2 will get cancelled. If I multiply throughout by under root of 1 minus x square, multiply throughout by under root of 1 minus x square. So can you say what will I get? Let me write it here. Multiply by under root of 1 minus x square. So here under root and under root will be whole square. So under root will be gone. I will get 1 minus x square into d2y upon dx square plus, sorry, here it will be minus because this minus is there. If I multiply it with under root of 1 minus x square, it will get cancelled. So I will be left with minus of x into dy by dx. And on the right hand side, again, this will get cancelled. M into m square. And what is this? This was y. So if you see, if I bring it this on the left hand side, then I will get 1 minus x square d2y over dx square minus x dy by dx plus m square y is equals to 0. So that means we got this value and it is option A. I hope you got it. Again, I'm repeating it many times because it is very simple. It is very simple. You just need to differentiate it 1 time, simplify it, and then again differentiate it 2nd time. So let us see one more example and you will be absolutely clear with what to do. So if I take the next example here, if y is equals to e raised to m tan inverse of x, then again we have to show this. So in the MCQs, this will not be there. We'll be given 4 options. That will be 0, 1, let's say suppose -1 and 2. Option A, option B, option C, and option D. So again, as you can see, we need d2y by dx square. That means we need to differentiate 2 times. The logic is same. What do? We differentiate 1 time. Let us differentiate it 1 time. So dy by dx. Okay. Let me use chain rule. Let u is equals to m tan inverse of x. So that means y is equals to e raised to u. So if I want to find dy by dx, I will differentiate y with respect to u, and then I will differentiate u with respect to x. So e raised to u is e raised to u. Differentiation of e raised to u is e raised to u. And if I differentiate this, I will get m is constant. And what is differentiation of tan inverse of x? 1 upon 1 plus x square. So let us resubstitute the value of u. If I resubstitute the value of u, what will I get? I will get dy by dx is equals to e raised to. Okay, let me tell you one thing here. Please let me tell you one thing. If y e raised to u, I can resubstitute y. So no need to write e raised to u. See here. In place of e raised to u, I can easily write y. This is what we call simplification. This is what we call simplification. So I can write dy by dx equals to y into m upon 1 plus x square. So now again, please avoid differentiating here again. Because if I differentiate it here, I need to use the division rule u upon v. As we did in the last question, what we need to do is simply cross multiply 1 plus x square. So we get 1 plus x square into dy by dx is equals to m into y. Now it is better here to use the product rule u into v instead of division rule, because division rule is more of calculative. So as you know, you will obviously you will get answer if you use the division rule here, but it will be more tedious. So let's see what we get after this. Now again, if I differentiate here, I need to use u into v rule. So I will get 1 plus x square into derivative of dy by dx. Now if I differentiate dy by dx again, I will get d2y over dx square plus dy by dx into 2x. Derivative of 1 plus x square is 2x is equals to, please be careful here, m is a constant. And what is the derivative of y? It is dy by dx. We are very close to the answer. We just need to shift it to left hand side. So I will get 1 plus x square into d2y by dx square plus 2x dy by dx minus m into dy by dx equals to 0. Still, if you cannot see, let me make you clear. We can take dy by dx common from here. So I will get 1 plus x square d2y by dx square, right? Plus, if I take dy by dx common, I will be left with 2x minus m. And on the right hand side, it will be 0. So what is the value of this? Is 0, means it is option A. So these are the questions which we may encounter while doing higher order derivatives. Now, let us again go through a recap of today's lecture. Today we started with derivatives, right? Yeah. So we have covered the basic formulae, the rules of derivatives, derivative of composite functions, and higher order derivatives. We had gone through all this, the formulae, the rules. We saw how to use the chain rule. Then we did some questions. And then finally we saw the higher order derivatives. Now, let me give you an example. A second. Yeah. Let me give you an example of the chain rule. Let's see now if you can talk, if you can solve. So, if I say, suppose we have used a chain rule only for two questions, and that were only two composite, you will see what I am doing here. Y is equals to, suppose, let's say, log of e raised to x square plus 1. So this is a function composed of three functions. So if you cannot see, let me make this clear how it is composition of three functions. So if I say let u is equals to x square plus 1, let v is equals to e raised to x, then e raised to x, nahin, e raised to, if I say u is equal to x square plus 1, then this will be e raised to u. That means my y will be log of v. Please understand this. If I take u as x square plus 1, I will get here e raised to u. And if I take v as e raised to u, my y will be log v. So if I want to find dy by dx, so y is a function of v, it will tell differentiate me with respect to v and let v be differentiated with respect to x. Now the same story continues and this will form a chain. So it will say dy by d is fine. Differentiate v with respect to u, since v is a function of u, and let u be differentiated with x. So now, if we use dy by dx, what is dy by? Okay, I made a mistake. Oh, dy by dv it should be. Yeah, this should be dy by dv. Okay, so dy by d, log v. Log v's derivative 1 upon v into dv by du. E raised to u's derivative e raised to u. Then du by dx, here we'll get 2x plus 0. That means 2x. So now let us resubstitute the values. What is v? V was e raised to u into e raised to u into 2x. And to your surprise, this gets cancelled. So finally, we get dy over dx is equals to 2x. So this is my answer. So let me tell you again, many a times there will be 3 or 4. And let me assure you, there will not be more than 4 composite functions. Here we have done till 3. 4 is also very rare. 3 is the maximum they will ask. So let us again go through how we use chain rule. For 3 composite functions, same dy by dv, dv by du, du by dx. So finally, my answer should always be in terms of x, because the variables u, v were assumed by me. So I cannot leave answer by variables assumed by me. I always need to leave the answer by in the where the variables are mentioned in the question. So that's it for today. And today is Thursday. Tomorrow we'll be starting with application of derivatives. It's a very interesting chapter. Real life problems we'll see there. That means how do we use derivatives in our day-to-day lives? What are the applications of using derivatives? So let me give you a brief. There are four to five applications of derivatives, and two of them are major, that are tangent normal, monotonicity, and maxima minimum. As I said, that the main aim of calculus is to analyze a function. Is the function increasing? Is given by monotonicity. Where the maximum value of the function occurs is given by maxima and minima. And that will help us to truly know the behavior of the function. So that's it for today. Let's end our class here and see you tomorrow. Okay, bye bye. Thank you. Take care, everyone. Good night, and you have a good day tomorrow. Chalo, bye bye.